This is Brian Von Axelson, Partner Solutions Advisor with the Microsoft Corporation. In today's screencast, we're going to take a look at SQL Server 2008 and extended events. Extended events is a general event handling system for server systems. The extended events infrastructure is a lightweight mechanism that supports capturing, filtering, and acting upon events generated by the server process. This ability to act upon events allows users to quickly diagnose runtime problems by adding contextual data, such as T-SQL call stacks or query plan handles, to any event. Events can be captured into several different output types, including event tracing for Windows. When extended events are output to ETW, correlation with operating system and database applications are possible, allowing for a more holistic system tracing. So let's take a look at SQL Server 2008 and extended events. All the metadata relevant to X-events is stored in system tables. X-event objects are stored in packages. Packages are binaries, but the objects within packages are described in the X-event metadata. So let's go ahead and take a look as I bring up a demo here. And I'm going to go ahead and execute this query. Here, this top grid in the results pane shows 3 X-event packages: package 0, SQLS, and SQL Server. The next grid shows the total count of objects by object type, and the last grid shows how the objects are spread across the packages. When creating event sessions, you often need to specify the package name. The most important X-event objects are events and targets. An event is, of course, an event. Targets are the consumers, or where event data are directed. Actions allow you to include additional information with the data that is already available for an event. You are not restricted to a single package when creating an event session. There's a great deal of events, many more than those available to SQL Profiler, and many at a much deeper level. Fortunately, the X-event metadata group these events into channels and keywords. So I'm going to go ahead and advance the demo and execute another query. As we bring up, the first grid shows all the available events sorted by channel and keyword. The channel can help a user isolate events that would be of most interest to them. A DBA may be most interested in the analytic channel. The debug channel includes events that may be more useful for customer support. The keyword further categorizes the event. As I scroll down to the second grid lists all the fields available for each event. This is data that can be received by a target and can also be used to filter events when creating or altering an event session. Now I'm going to advance to our next script, and we'll execute that and take a look at targets. Targets are the consumers in an event session. It's possible for a single event session to have multiple targets. The available targets include the asynchronous and synchronous bucketizer. This allows you to create buckets of events counts for a field available to the event. The pair matching targets allow you to record events that are missing a paired event, such as a resource lock without a subsequent release. The ETW, or Event Tracing for Windows target, allows you to send event data to a more traditional trace target. The second grid displays all the parameters for a target. These are values that can be specified when adding the target to the event session. So again, I will go ahead and advance, and we will go ahead and execute. Actions are performed when an event is fired and may be used to collect additional information that is available to a target. For example, the SQL server.sql_text action adds the text of the executing SQL query. So let's go ahead and continue with scenario 2 of our screencast today, as we are taking a look at X events. Here we're going to take a look at procedure and kernel analysis. Now I'm going to bring up some code that creates an event session to send SQL or SQL Server events to an ETW. Again, that's the Event Tracing for Windows session. The events include a couple stored procedures, the SP_statement_starting and the SP_statement_completed, which bracket a SQL statement executed within a stored procedure. The file_written and the file_write_completed events are also captured. Now, when adding the ETW underscore classic underscore sync underscore target, we do set the file path for the trace file to C:\demo traces. We actually name it sail tw2.etl. If this is not set, then we need to know the defaults. So the default target is going to be xeetw.etl, and it's going to be contained within the Windows temp directory. Now, because we want to filter the events to the current database, we build the SQL command as a string and run it using the execute function. This is just so this correct database will be filtered on any SQL server. We could have just specified the database ID in the create event session statement. The event session definition is persisted in system tables, so it takes just a simple transact SQL or just a simple T-SQL statement to turn event sessions on or off. So again, I'm going to advance and we're going to execute. And now we're going to start the Windows kernel trace using the logman utility from the command prompt. Here the trace output file is, again, C:\demo/traces/kernel.etl. I'm going to go ahead and advance again. First, we start the trace using the alter event session command, and then 3 stored procedures are executed. Since this target of this event session is a trace file instead of an in-memory target, we can actually use the alter event session again to actually stop the trace without losing our target data. Now, the first 2 stored procedures perform exactly the same work, except that the first uses 200 transactions while the second uses a single transaction. Again, I will forward the demo, and back at the command prompt, we use the logman utility again to flush the trace files and stop the traces. The xe_default_etw_session is the name of the data collector set for the SQL Server ETW session. The trace report utility, that's TRPT, is then used to merge the SQL Server and Windows trace logs into a single report. This file is ordered by the timestamp of the events, so the SQL Server and the Windows kernel events are intermingled. This intermingling of SQL Server and Windows kernel events is not possible using SQL Profiler. As I've opened up the output here, you can see that the trace report is a CSV, comma-separated file, which may be opened in Excel. In Microsoft Windows Vista and for 2008, trace report can also produce an XML file. So let me go ahead and close the Excel spreadsheet, and let's take a look at the 2 bottom panes. Down in the bottom panes, we have a grid summarizing some of the information available in the SP_statement_completed events, including the number of database writes, which is much higher in the SP_workload_1 procedure. The graph to the right of the grid shows the number of writes per stored procedure. We can then examine the output to see that the first workload stored procedure produces a significant number of disk I/O events with a small amount of transferred data. And I'll double click on the second workload stored procedure, and we can see that it generates just a few disk I/O events with a larger amount of transferred data. Now let's take a look at X-event procedure usage. The first step is to create a new event session. This session captures the SP_statement_completed event for the current database. This event is fired whenever a statement is executed within a stored procedure. The event session is then altered to add the asynchronous bucketizer target. This will keep a counter of SP_statement_completed events for each stored procedure in the database. For purposes of this demo, we will set the max_disk_path_latency, or how often the event session is flushed to the buckets, to 1 second. This low setting is for purposes of this demo. A higher setting reduces the impact of the event session on the server. The asynchronous bucketizer is an in-memory target and thus extremely lightweight compared to SQL Profiler. Parameters available when adding the targets, such as the number of buckets or slots, can further limit the resources consumed by the event session. The in-memory targets are appropriate for production systems. Here we've created the event session with the create event session T-SQL statement, and then added a target with the alter event session statement. The alter event session statement may be used to start and stop the event session, as well as modify an event session, such as adding a new event or a new target, or dropping an event or a target. The event session definition is persisted in SQL Server system tables. They can be created ahead of time and then started and stopped on demand. They can also be configured to start automatically when the SQL Server starts. The next step starts the event session and then executes a number of stored procedures called USP_demo_0 through demo 9. This creates SP_statement_completed events. The sequence does skip USP_demo_6 and 7. These procedures exist but are not called. Now we can view the event session results in the database. The event session needs to stay running or else the results are cleared. In the results pane, the top grid shows the raw XML stored for the event session. The results for an asynchronous bucketizer target are stored in a single table cell. The middle grid displays the count of times the SP_statement_completed event has fired for each stored procedure. It may well be worth examining stored procedures with a large event count. Also, applications which call these high-use procedures may need to be refactored. The bottom grid displays Deadwood stored procedures that have not been called since the start of the event session. These queries demonstrate how easy it is to return results from an aggregate in-memory target. Using the in-memory event consumers allowed a user to interrogate SQL Server directly for intelligence about behavior and bottlenecks, as opposed to manually analyzing trace files. Finally, the event session is stopped. However, the asynchronous bucketizer is such a lightweight target that it could be left running indefinitely on a production system with negligible impact. Since the configuration for the event session is stored in system tables, an event session can be configured to automatically start with the server. So let's wrap up today's screencast on extended events by taking a look at long-running queries. First, we create an event session for the SQL_statement_completed event. For the event, the SQL_text action is added so that the text of the SQL query is included. A predicate clause filters the events to those with a duration time greater than 2 seconds. The CPU time could have been used instead. Next, the session is altered to add the synchronous bucketizer target. The asynchronous bucketizer target could have been used just as easily. In this case, the value being bucketed is the SQL_text. Since this is an action, the source_type parameter for the bucketizer must be 1. The create event session and alter event session statements allow us to define very precise criteria for which events are considered and how they are filtered. We can also extend the data already collected with the event with actions, such as this example with the SQL_text action. Other actions include collecting a stack dump or a query plan handle. We start the session and then run the USP_CPU_hog stored procedures. The two parameters control the amount of work that the stored procedure performs. The last two calls should exceed our threshold. Now that we have run a few queries, we can see if any have exceeded our threshold of 2 seconds. First, we can query the raw XML that is stored for the synchronous bucketizer target. The second query parses the XML into tabular results. This displays the text for each query that exceeded the duration thresholds, plus a count of how many times that exact query has been executed. Finally, the event session is ended. Since the event session has only an in-memory target, the session data is lost once the session is ended. And speaking of session ending, that brings us to the end of this screencast as we took a look at SQL Server 2008 and extended events. Again, this is Brian Von Axelson, Partner Solutions Advisor with Microsoft. Thank you for joining and have a great day.